Our first lesson for trigonometry is based on the tangent ratio, which is lesson 2.1. So the starter is saying that they're giving us a hypotenuse of 17 centimeters. So what we want to always do is label our longest side. So that's always called our hypotenuse, which I always shorten to HYP just to make it easier and less writing. So we're going to label that with 17 centimeters. So what we need to remember is that a squared plus b squared equals c squared. So our two legs, when we square them individually and add them together, we're always going to get the hypotenuse squared. So they're saying what numbers would work? Well, 8 centimeters and 15 would work, even if I switched them. So if I made B8 and A15, it would work, because 8 squared plus 15 squared equals, so let's use our calculator to figure that out. Okay, so 8 squared in my calculator plus 15 squared gives me 289. And now we want to square root that 289. Square root of 289 gives me 17. So always make sure you square root the final answer in order to get your C by itself. So that means you're going to get 289, and the square root of 289 is 17. So that's how I knew that it worked. So 8 and 15 are my other two sides. When are two triangles similar? Similar means that they have the same angles inside. Same angles, but different side lengths. So we want to remember that they have the exact same angles, but one could be bigger than the other. So they could both be right triangles. They could be any type of triangle. Let's say this was 60 degrees and this is 30. This would also have to be 60 and this would be 30. The only difference would be that the lengths would be different. So this could be a 2 to 5. There's a 3 to 6. Actually, that wouldn't work because the hypotenuse has to be biggest. So let's put like a 1 and 0.5 here, and here a 3 and a 2 here. Okay, so that would be an idea. So as you can see, the side lengths are different, but the angles are the same. So same angles, but different side lengths. The angle of inclination is always where you look at the x-axis, and it's an angle created from a horizontal line. So we're looking at a horizontal line. Usually we're looking at the x-axis, and we're making an angle to that. We're creating a line that's kind of cutting through that x-axis, and the angle that it creates is your angle of inclination. So when we label this, we always call this our vertex or our origin. And then this is called our terminal arm because it moves. This one will go up and down depending on how big or how small our angle is. And this is called your initial arm. It doesn't change. So that should stay put. So we have an initial arm, we have a terminal arm, we have the angle that's created between them, and we label that with theta, which is a Greek symbol to represent angles, usually if we don't know them. So we're going to label the triangle. So what we want to do is always label our triangle with the letters that they give us. In this case, we start with a letter A. If you guys can see, there's a letter A. So let's label our triangle A, B, and C. So what we're going to do is mark off A because that's the angle we're looking from. From there, one side length should always be called your hypotenuse coming out of that A. So we're going to label it with hypotenuse, or HYP for short. The other arm coming out of it should always be labeled as your adjacent side. ADJ, or the long way this is called the adjacent side. And lastly, we have OPP, which is our opposite side. So it's opposite to the angle that we are looking from. So our first ratio that we're going to be exploring is the tangent ratio. So that's where we take our opposite side and divide it by our adjacent side. So this can help us form and create and find these missing pieces. So using this formula, I can either find angle A if it's missing, either the opposite side or the adjacent side, but only one of these can be missing in this equation. So that's our first ratio. So to remember this, we use TOA, T-O-A. Tan is equal to opposite over adjacent. So O represents opposite, A represents the adjacent. So opposite over adjacent. So let's try example number 1. In this case, we're looking from angle X. So you're going to kind of highlight angle X. We're going to put that little theta symbol to represent the angle we're looking from. And we need to start by labeling our sides of our triangle. The longest side will always start by labeling with the HYP, which is our hypotenuse. So as you can notice, that's one of the arms coming out of X. The other arm should always be called your adjacent side. So this is going to be your adjacent side coming out of X. And then the missing side, the side opposite to your angle, should be called OPP for opposite. So in order to find tan of X, we always have to do TOA, T-O-A, opposite side over adjacent. Our opposite side is labeled with a number 6. So we're going to replace OPP with number 6. So that's the number that we see right there. And adjacent is going to be represented and replaced with number 12. With our answer, we need to simplify. So we can't just leave it as 6 over 12. We need to either, in our calculators, divide the top number and the bottom number by 6. So we're going to divide this by 6 and this by 6 to simplify. So the key word is always simplify your fractions. So that's going to be 1 over 2, or 1 divided by 2 is 0.5. We can write it as a decimal. So the reason that we sometimes prefer fractions is because we can clearly see what the opposite side is and what the adjacent side would be if you simplified it. Now we're going to do the same thing for tan of Z now. So in this case, we're looking at tan of Z. So first you're going to highlight Z and label that as your theta. So this is the angle we're looking from. The reason that's important is because our labeling of our triangle changes depending on what angle we are looking from. Our hypotenuse always remains the same. It's still always the longest side opposite to your 90-degree angle. And then the other arm coming out of it, so we know that one arm should always be coming out of Z as the hypotenuse. The other arm coming out of that same Z should always be labeled with your adjacent, ADJ. And lastly, the opposite angle would be this one, the XY. So we're going to start off the same way. Tan of Z now is equal to opposite over adjacent. So that's the formula we have to use if they want the tan of something. Our opposite side should be labeled as a 12. So we labeled OPP as 12, and our adjacent side we should label with a 6. Now use your calculator. 12 divided by 6. 12 divided by 6 equals 2. So as you can see, 2 is your answer. So that's our tan Z ratio. Okay, so these are our two answers that we got. From the first one, we got 1/2 or 0.5. And our second answer, we got 2 as our tan Z. Okay, so again, the answer will change depending on what angle you look from. So make sure you label your triangles correctly. That's the biggest thing you need to know from this lesson. Now we're going to determine the measure of angle K. So I'm going to show you how to use the ratio of tan to find out your angles. So step 1, we're going to look from angle K. We're going to label it and mark it off. Let's start with angle K. From there, we have to label our sides. The longest side, which is our KN, should be labeled with hypotenuse, HYP. the other arm coming out of K should always be labeled with the adjacent. So whatever side you didn't label coming out of the hypotenuse, out of K is the hypotenuse, the other one is the adjacent side. And then the opposite should actually be opposite to your angle K. So opposite to angle K is OPP. So let's start by writing what our tan of K is. Tan of K is equal to, we know the opposite over adjacent is what we need to use when we're talking about tan. So let's keep going. Opposite side we know is 9. So we're going to replace OPP with number 9 from this part right here. It tells us that it's 9. And our adjacent side is 13. So we're going to replace those numbers to find out 9 over 13. The issue is now we have to find out what this is. We need to get the K by itself. So the trick is, in order to isolate for K, you have to get this to the other side. So there's actually a trick to it. In order to bring tan to the other side, it becomes something called a tan inverse. And this is what it looks like. You're going to go tan inverse of 9 divided by 13. Okay, so you're going to find the inverse button. Tan inverse. And in your calculator, you're going to go 9 divided by 13. Now, when you're trying this in your calculator, what's really important to notice is, does your calculator at the very top say DEG? DEG. So what you want to do is on your calculator, find the button mode. So do you guys see how there's a mode? And you want to make sure that you have degrees highlighted. So there's different types of math symbols and stuff. And you want to make sure that degrees is highlighted. So sometimes there's a button called DRG. And if you keep pressing that, that will take you to degree mode. Now, for this unit, you have to make sure that this is the trick to know that if you're in the right mode. So everybody should be putting this in their calculator to see if they're in the right calculator mode. Otherwise, every answer you get could be wrong. So I'm going to put tan. So find TAN. Do you guys see that? Tan, 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 tan. This is my tan button. I'm pressing on it right now. Okay, so find TAN, tan. And I want you guys to press 45 and close your brackets. Some of your versions, you'll have to do 45 and then press the 10 button. Do you guys get 1? If you're getting 1, that means your calculator is doing well. It's in the right mode. If your calculator is not in the right mode, you're going to have to change it to the right mode by pressing DEG. So DRG sometimes for certain calculators. Some calculators you're going to have to go to mode and make sure degrees is highlighted. So there's a few kind of steps that you'll want to make sure. So make sure, hint, hint, make sure your calculator is in degree mode. If it's not in degree mode, then tan 45 will give you some weird answer other than 1. So make sure tan 45, this is like the test. Test out tan 45, is it equal to 1? Because if it is, you're fine. Okay, so let's calculate this tan inverse of 9 divided by 13. So it's all about making sure you know where these buttons are in your calculator. Okay, so everybody should be finding, usually it's above tan. Do you guys see right above tan in green? I have this tan -1. That's what tan inverse is like. So I'm going to go tan inverse. And it usually opens up a bracket depending on what calculator you have. And then you're going to go in brackets. 9, you're going to divide by 13. So we're trying to find the tan inverse of 9 divided by 13. And it should be this. So this is how you know that you're getting the right answer. You're getting this 34.7 degrees if you round to the nearest tenth. So 34.7 is what I'm going to write down. Okay, so tan inverse of 9 divided by 13 was equal to 30, let me write that down, it was 34.7. Okay, so everybody should be finding that for any graphing calculators, you would press second tan. and 9 divided by 13. You should see that little kind of 10 with a -1 if you're doing the right numbers. Now, if you are if you're on a graphing calculator, make sure that you have degrees highlighted. You're going to mode and highlighting degrees. So only if you're in degree mode will you get this answer. So if you're not getting the right answer, it's because you're in the wrong mode. Remember that. Okay, so what we're going to do is we're going to label our K angle with 34.7. It says to round to the nearest tenth of a degree, which is y rounded to 1 decimal place. Okay, so we also know that on a triangle, whenever you have that little square, that's actually 90 degrees. So every square little piece should always be 90 degrees. We have to find angle N. What you guys need to remember is that all angles in a triangle should always add up to 180. So what we can do is to find out angle N, we have to do 180 degrees minus the other two angles we already have. And that will give us the missing piece. So 180 degrees is all three angles, what they should add up to. You're going to subtract the 34.7 from it, and you're going to subtract the 90-degree angle, and that will give us the missing piece, which is angle N. So in your calculator, you're taking 180 minus 34.7 minus 90, and you should get to the nearest tenth, 55.3 degrees. So those are your answers. Example number 3. Clyde River on Banff Island, Nunavut, has latitude of approximately 70 degrees. The diagram shows the side view of some solar panels. Determine whether this design for solar panels is the best for Clyde River. Justify your answer. So what we need to do is figure out if this angle is 70 degrees. If it is, then it's going to work perfectly with the latitude that we're given. So what we need to do is find this angle right here, this theta, this missing angle. So we're going to do something very similar to what we just did. So first, label your sides. Always label your longest side with HYP, which is your hypotenuse. The other side length coming out of that angle that you're looking from, should always be your adjacent. And then we have our opposite, which is that leftover side, which is actually opposite to our angle that we're looking from. Then we always start by writing tan of our angle is equal to our opposite over adjacent. So TOA. TOA. Remember that. TOA. TOA. Our opposite side is 208. And that's tan of theta. Our adjacent side is 70. The next thing we have to always do is we have to bring this to the other side of the equation. And for tan to move to the other side, we have to do its opposite. So the opposite of tan, when we bring it over, is called tan inverse. And that becomes tan inverse of the ratio that we have on the right side. So tan inverse, in brackets, you have to put 208 of 70 in there. So this is where we switch to our calculators. And as long as we're in the right mode, we should be able to get the right answer. Okay, so back to our calculators, we're going to go tan inverse. So for some of you with scientific calculators, you're going to do shift tan. For graphing calculators, you're going to press second tan. And then the numbers we're using were 208 and 70. 208 divided by 70. Close your brackets, and you get this answer here. Okay, so you'd press enter. You should be getting 71.4 if you're getting this correctly. So, so we'll say that it's not bad. Like if we're looking at the angle is 71.4 degrees. We'll say that the angle is 71.4 degrees if we round to the nearest tenth. So it's pretty close, but it would be better if it was exactly 70, right? So we would prefer one that was exactly 70 for it to be the best design, right? So this is close, but not exactly 70, so not ideal. If it was exactly 70 degrees, it would hit and get the most kind of benefit from the sun and get the most power. Okay, so we were able to find that angle by using the opposite and adjacent side. And don't forget, when you want to find an angle, you use tan inverse. Our last example is where we have to draw it. So sometimes you're going to be given a situation where you need to draw the situation from reading it. So we have a telephone pole. So I'm going to start by drawing the telephone pole. And they're telling us that there's a support cable that's going to be attached to it, going to the ground. So it's always going to create a 90-degree angle with us. For all these kind of lessons, we're always going to have this 90-degree angle being created. So the support cable is 5 meters from the base. So the base is the bottom. Okay, so on the ground, we have 5 meters away is where we anchor this cable. The cable is 19 meters long, which is actually our hypotenuse. It is attached to the top of the pole. What angle to the nearest degree does the cable make with the ground? Now, first of all, if we want to use our tan, we're going to have to look from a certain angle, and this is the angle they want. So what angle does this cable make with the ground, which is this right here? So when we're labeling our sides, we know that the longest side is always our hypotenuse, which we already labeled. The other side length coming out of that angle is always called our adjacent side, which means that this is our opposite side. Now for TOA, we need to remember that tan is equal to the opposite over the adjacent. We don't have the opposite side, so this is where we're going to have to use Pythagorean theorem to solve for our opposite side. So we can either put A or B as our opposite side, it really doesn't matter. So we can say opposite squared plus our adjacent squared, which is our legs, 5 squared, equals our hypotenuse of 19 squared. So I'm just replacing 5 into either A or B, and our hypotenuse always has to be, in this case, 19. So we're going to calculate each one of these and solve for the opposite side. So 5 squared is 25, using my calculator. 19 squared is 361. Now, in order to get the opposite by itself, we have to isolate. We have to bring this 25 over to the other side by subtracting it. So we want these guys gone. So we want to get opposite by itself. So 361, we're subtracting 25 to it. $361 take away 25 is 336. Now we need to get the opposite by itself by square rooting. We have to get rid of that little 2 by square rooting both sides. So you're going to square root 336. And your opposite side will be a decimal, which is approximately 18.3, and that will be in meters in this case, meters. So we now know the opposite side. So now that we have the opposite side, now we can use tan. Tan theta, which is our angle, is equal to always the opposite over the adjacent. So if we don't have a side, we can use Pythagorean theorem to find that missing side. The opposite side is 18.3. The adjacent side is 5. So just like in the previous examples, we have to get our angle by itself by doing tan inverse of 18.3 divided by 5. So we had to bring this tan to the other side, And when it moves sides, it becomes tan inverse. So don't forget to do tan inverse when you move it to the opposite side, because we're trying to get the angle by itself. So this is where we're going to switch to our calculators. 18.3 over 5. So step 1, you're going to press shift tan to get that tan inverse, or second tan to get the tan inverse. And then we're going to have to do 18.3 in our brackets, divided by, our other side was 5. So opposite over adjacent, 5, close our bracket. So you should be getting 74.7 degrees. So I did tan inverse of our opposite over our adjacent, 74.7. Now make sure you read the question correctly, because it does say to the nearest degree. What angle to the nearest degree does the cable make with the ground? That means whole number. That means you should have no decimal places in your answer. So we're going to have to round our answer to 75 degrees. So we're going to have to round it up to get our final answer. So therefore, the cable creates a 75-degree angle to the ground. Okay, so that's it for our example number 4. So what you need to be able to do is write the ratio and then use the ratio to solve for an angle by always doing tan inverse. So don't forget to use tan inverse if you're trying to solve for the angle. So examples that you can practice right now to get this idea in your head is on page 75 to 77 in your textbook, day 1, and these are the questions that you can try to make sure that you understand these. So these are good ones to practice. Thanks guys for joining me.